Okay, we're back. This is Techmath1. We're looking at review 3. Big calculator test here. You have to have a calculator for sure. I think with a calculator, if you know how to use it, you should be able to breeze through this test pretty quick. I'll still leave the same time limit on there, but I don't think you're going to need anywhere close to 2 hours. All right, so here goes. Let's take a look. So here they gave us D, H, M, and S. You just substitute that in. 20.7, 590, 8.22, 11.6. This is review 3 for chapter 5 and 6. Okay. All right, so we just sub that in. Now, in your calculator, you could code that in. I'll show you how to code that in all in one step if you want to. Minus 590, and then you'd have to do divided by, and then a parenthesis, and then 8.22 times 11.6, end parenthesis. And then if you just code it in like that and hit enter. This is the calculator section, so if you want to do it with that, that's fine. If you want to show some work along the way, that's fine too. Doesn't matter. You can either do it all in one shot, like this, and hit enter, or you can do it in stages, or you do 590 divided by, you know, figure 8.22 times 11.6, write it on the bottom, divide it into 590, and then subtract. All right, next one, just again, plug and chug. So 852 for R, 548 for T, 175 for G, 319 for W, and 852 and 548 again. And again, you can do it in stages if you want, that's fine. Or again, if you wanted to type that all in, you'd have to put parentheses around that, and then divide it by, and then parentheses around that. So if you wanted to key it all in one shot, it would be a parenthesis, 852 times 548 minus 175 times 319, end parenthesis, divided by, and then a parenthesis again, 852 times 548, end parenthesis, and then just hit enter. And that'll do it all in one shot. I did it in a couple of stages, so I ended up with 411,071 divided by 466,896. I got this for an answer, 0.88043378, but then make sure you round. This one says the thousandths place. All right, this was the same chapter that we talked about precision and accuracy. So thousandths place would mean you'd put that 0 there. All right. So we would know it is precise to thousandths. On this one, that's the rounded answer, but the pre-rounded answer looked like this. 0037, just so you can check it off with your calculator. All right. Awesome. Next one. Again, plug and chug. And again, I did post the key, so you can look that over. You're only watching this, I guess, if you didn't understand the written key very well. Or you just like that classroom feel. Either way, it's fine. All right, so 3, more of the same, just plug and chug. And again, this is very, very similar to the test that they gave us. That. So there's a squared this time, so that's a different key you got to use in your calculator. So 120 squared over 2 times 50, or 32, 32.2. Okay. And so 120 times 120, that's 120 squared on your calculator. There is a little just x squared key you can hit, and it'll just throw the squared there. Or if you want to use the caret key to the second power, that's another way to do it. Either way is fine. So 120 squared, and then hit enter. If you want to do it in steps, I did it in steps again. 14 1,400 divided by 64.4. And then you actually divide it, type that in and divide it, and you get 223.6024845. And then they said a whole number, so that would take it to 224. All right. Again, if you wanted to key it in all in one shot, it depends on how new your calculator is, because you might have to, I talked to somebody earlier with the squared. If you have a newer calculator, with an older one, you just hit the squared button, it'll throw it there, and then the next thing you do won't be up in the exponent. But if you have a newer one, then you're going to have to right arrow. You're going to have to hit the right arrow button on the graphing calculator to pull it out of the squared to then do the divide. Otherwise, all this will be squished up there, and you will not get the right answer. That's if you want to do it all in one shot. All right. For same thing. It's a square root, so I guess it's a little different. C is equal to the square root of 1 minus h, capital H over little h. So we substitute 1 minus 75.3 divided by 91.8. So that's a really ugly little square root. So you might want to do that all in one thing. To find the square root key, if you wanted to have that in your calculator, you'd hit second and then x squared, and that'll bring up a square root. It'll look like this with a little parenthesis already on it. And so square root is asking what times itself gives you that number. So if I had like the square root of 25, that's just 5. What number times itself gives you that number? So this would be 1 minus 0.820261438. I did not round at all. 0.1797562, and then you take the square root of that number, and that gives you 0.423955849. And then if you round that to 3 decimal places, that's 0.42. Oh, there we go. And so if you wanted to key that all into one shot, oh, that wouldn't be that bad. It would be like this. You would hit the second x squared. That would give you this. And then you do 1 minus 75.3 divided by, but when you hit the divided by symbol, it'll just give you one of these. And 91.8. And then 1 end parenthesis, and that should do it. That'll take this, that'll do the division, do the subtraction, and do the square root all in one shot and get you right to that answer. So again, there's no rule that you can't do it in little steps if that's easier for you, or if you want, do it in your calculator all in one shot. Just make sure if you're doing it in the calculator all in one shot, because you're saving all that time of writing all that work down, maybe do it twice and make sure you get the same answer twice. So that, if you just accidentally put in 7 in where there was supposed to be an 8 or something, you're going to probably lose all the points on it because I'm not going to have any work to see. Where I guess that's the advantage of like writing it out a little bit and showing some work. If I can see where you made your mistake, I won't take off as many points. All right, so then S is equal to the cube root of V. And they gave us V to be 260. So this is all about entering it into your calculator. Again, I think you can go into math and numbers and then go down and find the cube root of. It's a lot easier. I'll show you the easier way to do it. 260 do the little caret. That's the power key. And then do a parenthesis and then 1 divided by 3. Again, if you have a newer calculator, if you bought it recently and it's got like a color screen on it, it's the newer TI. When you hit that key, it'll pop it up there, and you don't really need the parentheses then. Then you can just do 1 divided by 3 if it's hanging up here. But if it's an older one like the one I have, then you have to do the parenthesis because otherwise it'll take 260 to the first power first and then divide the result by 3, and that will not give you the right answer. All right, so I want you to get the right answer. That turns out to be S is equal to 6.382504299, and so S is equal to 6.38. Again, the cube root, in the same vein as a square root is asking what number times itself gives you that number. A cube root is asking what number times that number times that number gives you that number. So like the cube root of 8 is 2, because 2 times 2 times 2 is 8. So it's the same concept as square root, but with 3 numbers instead of just 2 numbers. All right. Let's keep going. Number 6, again, more plug and chug. They're just throwing big numbers at you. And again, you could do this in your calculator. I didn't. I did it. I mean, I used the calculator to do the final division, but I took it out of scientific notation. And so, 1, 2, 3, 4, 5, 6, 7 zeros. And then I took the bottom one out of scientific notation. 1, 2, 3. 450,000. And then I divided those two numbers. And it gave me this, 66622.22222 forever. And then they wanted it rounded, scientific notation with 2 decimal places. So what that means is I change it so it's 6.66. That's what they mean. They mean 2 places after the decimal, after you move it. So they don't mean here. They mean first move it 1, 2, 3, 4 places. So that's times 10 to the 4th power. And that's our answer. All right. If you don't want to take it out of scientific notation, you don't have to. You can make the calculator do all the work. Do a parenthesis 2.998 times 10, little caret to the 10th. All right. And then end parenthesis, and then divided by, and then parenthesis 4.50 times 10 caret to the 5th, end parenthesis. You type that in and hit enter, and it'll give you this answer. You'll still have to put it in scientific notation by yourself. All right, so you're doing that. Number 7, the resistance of 1 foot piece of quadruple zero aluminum wire is 8.04 times 10 to the negative 5th ohms. What length of wire has 1 ohm resistance? So we're going to want to take the length divided by the ohms. So that's 1, because it's 1 foot piece they gave us, and 0.0000804, right? Because it was times 10 to the 5th, so I took 1, 2, 3, 4, 5 places to the left. So that's how I got that. And again, you just do this trick again, where you just take 1 divided by, and then do the parentheses in that. So that turns out, when you divide that, to be 14,097.90694. And now you have to read this carefully, because it's like this on the test too, so be very careful. There is a hundredths place, but that's not what they said. They said round to hundreds with a D at the end, hundreds. So ones, tens, hundreds, that's this place right there. So that 9 bumps it up to a 1, 14,100. That's my answer. So be careful, read it carefully. I think a lot of students kind of fall into the trap of always thinking in terms of decimal. And so it does not have hundredths, it's hundreds, which is extra confusing because there are decimal places there. And we're used to the hundredths, THS at the end. All right, so beware. All right, 9, geez, more of the same. Lots of these plug and chug problems. I'm hoping we really knock this test out of the park, everybody. Minus R, minus R. Okay, so we're plopping it all in. That's 2, that's 860, that's 18, that's 43 minus 18, that's 56 minus 18, and again, I crunched it all out and did 1720 over 17,100, and then divided it and got 0.100584795, and then it says round to hundredths, this time hundredths, and so there's hundredths place, and there we are. All right, number 10. Okay, finally something different. We're gonna look at 12,320 yards is how many miles? So you write 12,320 yards, and now we're going to multiply it by fancy 1. And again, if you look at the key, I actually looked it up for you in the book. In the blue book on page 237, they've got that conversion. There's also like a sheet that came in your packet that has all the conversions on it. So if that's more convenient, you could totally do that. But with the book, it's probably got an example right there for you too, which I think makes it a little easier. So either way though, you can use the sheet or the blue book on the pages. This one was on 237. How many yards are there in a mile? That is 1,760. I guess maybe some of you even know that. That's fine if you just know it off the top of your head. Awesome. All right, so now what happens are yards cancel. This is over 1. Yards cancel with yards, and then we multiply top times top, bottom times bottom. And normally I say reduce, but since this is a real life problem, we're not reducing, we're dividing. We're just dividing it. If it turns out to be a decimal, so be it. If it comes out even, that's great too. This one happens to come out even. It's exactly 7 miles. All right. So 1 mile is equivalent to 1,760 yards. So this is essentially like multiplying it by 1. The thing we did was we traded out the labels. And so, you know, if this would have been miles and they wanted yards, I would have just flipped this around and the miles would have canceled. I would have been left with yards. All right. Okay, so now we're going to do a bunch of these. 15 grams is how many hectograms? And so again, that's in the blue book on page 242, where you're counting left or right. And so that ends up from grams to hecto. We take it from the decimal where it is, 2 places to the left to get to hectograms, so 0.15 hectograms. Next one is centimeters to inches. So that's a completely different conversion because we're going from metric to English. So 20.6 centimeters. But I want centimeters to go away, so I'm going to do this same trick on that one. When it's metric to metric, you're just moving the decimal one place or the other. You just have to look it up. But when it's metric to English, you got to do one of these. So that is found on page 244 in the blue book, if you want it. Or like I said, you can use, you've got like a sheet that came in your packet with all the formulas on it and conversions. So centimeters cancels, top times top, bottom times bottom. You get 20.6 over 2.54, and then you just divide it. It is now in inches. So you actually divide that out. Remember to divide it out. Once in a while I get a student or two that leave it like that. Don't leave it like that. Divide it. You get 8.11023.622 inches. And on the test it'll clearly say 100ths place, okay? On the review it didn't. So that's a mistake they made on the review. You should always be told how many places you want for precision. All right? Okay, let's continue on. 13 is a little trickier here. I'm going to erase both of these, so last look. 13, we're actually doing 2 conversions, possibly 3 if you don't know how many seconds there are in an hour. There are 60 minutes in an hour and 60 seconds in a minute. So if you take 60 times 60, that is 3,600. That's how many seconds there are in an hour. So we're going to need that because they want us to convert 9 meters per second into kilometers per hour. So 9 meters in 1 second. So we're going to have to deal with two things. So I'm actually not going to do the move it to the right or to the left. You can if you want to. Because, right, we'd have to go from meters to kilometers, so that would be 3 places to the left. What I did was I set it up like this, so you can see it cancel. I said there's 1 kilometer, and in a kilometer there's 1,000 meters. So like that meter stick that's in the room at the front by the board, it's, if you set 1,000 of those end to end, that'll be a kilometer. All right. So that will cancel those. That's why I did it that way instead of just moving it. And then seconds, I want it to go away. So I'm actually putting that on top because right now it's on the bottom. So I want it to go away. So seconds on the top. And then I want hours replaced on the bottom. And so this is the 3,600 seconds in 1 hour. Okay. If that didn't jump out at you, you would have went from seconds to minutes and then minutes to hours. There'd just be 2 of them. But both of them would be on the top. You'd have 60 times 60 and you'd get 3,600. So this seconds now canceled. So now look at what I have left in labels. Kilometers per hour. That's just what I wanted. And 9 times 3,600 on the top. That's 32,400. And then on the bottom, 1,000 times 1 times 1, that's 1,000. And then I divide it and I get 32.4 kilometers per hour. All right. Okay, 14. A little different still. We got 100 degrees Celsius, and they want us to convert that to Fahrenheit. Again, that's in the blue book on page 252. So this is an actual formula. It's a little more like the first page stuff, and a little less like this. We don't get to just multiply it like that. So it's actually, you take that, sub it in there, and then figure it out. So 900 divided by 5 is 180. 180 plus 32 is 212 degrees Fahrenheit. Okay. And then the last conversion one here, we'll squeak that one in here. That wanted us to go from picoseconds to microseconds. All right, and so again, Blue Book page 259 for that one, or use your conversion sheet. But if you count, it's actually 6 places. That's 6 places left. So 1, 2, 3, 4, 5, 6. So 0.0075. You don't really need the other 2 zeros in this case. If you put them there, I would mark it wrong. It's fine, but you don't need it. All right. All right, then 16. Note on 16, they messed up letter D. They typed it wrong. Typo on your answer key sheet. There is a typo. All right. Where the answer should have been 9.62, but they didn't write that down. Okay. Yeah, I'm just gonna keep going. Put the whole review on this thing. All right, so we got 725.7, a 0.0310. We got 54.96. We've got 18.705, and we've got 9.62. I don't know why they messed this up, but they did. So look, let's figure out sig digs. This has 4 significant digits. 1, 2, 3, 4. They're all numbers. This one only has 3 because the 0 doesn't count. So 310. Oh no, that's right then. Then this is the one. This is better than that one. Ah, shoot. Okay. Never mind. There is not a mistake on the key. There is not a mistake on the key. There is not a mistake on the key. 1, 2, 3, 4. And I'll show you why. 1, 2, 3, 4, 5. And 1, 2, 3. So this is going to be a tie for accuracy. Precision, easy peasy lemon squeezy. The most precise. So the greatest precision is just the most decimal places, so that's this one, wins. All right, that is the greatest precision. And then B, least precise, that would be the 1 to 10th place. So this one was the 10,000th place, this one is the 10th place. So least precision is 725.7. And now greatest accuracy, that's still easy. That is greatest accuracy is the one with the most significant digits, which is that, so 18.705. But now least accurate, that is a toss-up. The one that's least accurate is because this has 3 and this has 3, so then you have to do that trick where you take 0.0, however many places that is, so 0, 0, 0, 0, and then throw a 5 on. So 4 zeros and then a 5, and then divide it by the original number. That gives you relative error, okay? And same with this one. We got 2 places, so that's 0.00, and then you throw a 5. 0, 0, so to hundredths place, and then throw a 5 out into the thousandths place, and then divide it by the original. And now the one with the lower number is the more accurate. So this one turns out to be like 0.000, there's like 4 zeros, and this is only like 0.00 something. So this one is actually less accurate than that one. So 0.0310. This is the answer. That one is got a smaller relative error. If it's a smaller number, then it's more accurate. And so this one is more accurate and that one is less accurate, and they wanted the least accurate one. So yeah, if you actually divide those, you get really small numbers. All right? But this one will be smaller. Okay. That was a little bit of a tricky one. Then 17 and 18, they make you decide. They don't tell you round to anything. You have to figure out, should I be using precision or should I be using accuracy? So look, on 17.712 plus 0.850 plus 0.0564, well, I add those all up, I get 1.6184. But when you're adding and subtracting, you should use precision, and it should be the least precise thing up there. That determines what you round to. So this went to 10,000ths place, this went to thousandths place, this went to thousandths place. So we're going to round to thousandths place. Okay? If we were to report it out as it is, then the assumption is you went out to 10,000ths place on the whole calculation. That's why you always go with the smallest, the worst precision. Okay? 18. With division and multiplication, which they got both in this problem. 8.6. All right? With division and multiplication, you use accuracy, and again, the least amount of accuracy, because you don't want to misrepresent. Okay. So the least amount of accuracy on this one. Let's see. This has 1, 2, 3, 4 sig digs. 1, 2, 3 sig digs. 1, 2 sig digs. So our answer is going to just have 2 significant digits. All right. So I multiply those together and then divide it into that, And I end up with this for an answer. 1.427485036. But I only get to use 2 significant digits. So in that case, it's just those 2 numbers. I can't do any of that. If it was big enough, I could have rounded it to 1.5, but it was 2, so I just left it 1.4. All right? All right. I think on 19 and 20 and 21, I'm going to do, 19 I can do here. I'll do 19. But 20 and 21, those are graphing ones. And I'm going to do a different video where you can see my graphing calculator. I'm just going to point the camera at the graphing calculator on a desktop and do those. So that'll be a second video called, graphing calculator 1. And I'll show you what buttons to hit to make it find zeros. Okay, but this one, 19, this one they wanted you to program the calculator. We're not programming it. We're just going to use this formula. On the test, the formula will be given. It's the compounding interest formula. They're calling it Y instead of T. Normally this is a T for time in years, but they called it Y, which, whatever, it's fine. I'll give it to you like that in the formula. So it's like back to the first page. One trick on this guy, they give you the rate as 6.8. That's percent. And so you have to change it to a decimal 2 places to the left before you insert it, okay? Okay, and then you divide that and add the 1, and you should end up with this 1.005666666, a bunch of 6's in there, to the 192nd power, still times 5500. So then you take that to that power. It's just a scooch over 1, so it doesn't really grow like you might have thought it was gonna. And then times 5500. And so you end up with $16,275.76. There's still more after it, but it's money. So $16,275.76. Okay. And then I'll do another video where I show you how to use the graphing calculator for 20 and 21. Ooh.